Hi friends, here we have three really basic problems that have come in CAT. Let's look at those. How many consecutive zeros in the product of all prime numbers below 100? Right. So all prime numbers below 100, the product of that and how many zeros are there at the end of that product. For example, 2 into 3 into 5 into 7 into 11 into 13 into whatever. Right. That is the product we are looking at. 2, 3, 5, 7, 11, 13, etc. Right. If you notice, when will a 0 come? 0 will come when there is a combination of 2 and 5. Right. That is the only case where a 0 will come. For example, in 10, 10 is 2 into 5. 20 is 2 into 2 into 5. Right. 4 into 5, which is actually 2 into 5. The second 2 is actually useless. Right. 30 is 6 into 5, which is 3 into 2 into 5. Right. This is 2 into 5. This 3 is actually useless. 3 doesn't contribute to the 0. This 2 and 5, they contribute to the 0. Now, here in this question, how many zeros? That means how many 2's, how many 5's are there in this multiplication? If you see, because it is about prime numbers, there cannot be more than one 5. Because once you encounter a second 5, for example, 15, 25, these are all multiples of 5. So there is no way a second 5 can come. In second 5 can come for a prime number, right? And there is no way another 2 can also come. 2 or a multiple of 2. Because any multiple of 2 is even number and it is not a prime number. Right. So there is only one 5 and only one 2 in this, irrespective of that. Even if there are multiple 2's also, don't it doesn't matter. Right. Even if there are multiple 5's, if there is only one 2, or if there are multiple 2's, but there is only one 5, doesn't matter. So it is intersection of 2 and 5. In this case, 2 and 5 together come only once. 2 also is coming only once, 5 is also coming only once. So there is only one 0 at the end of this product. Right, guys? This is such a simple problem. Next, next in this very basic question, I don't know why they have given this question. Again, this is also again in CAT 2000. Such no brainer. Here they are saying x, y, z are three distinct integers that are odd and positive. Which one of the following statements cannot be true? X, Y, Z. All three are odd and positive. You can take 1, 3, 5, 2, 3, sorry, 1, 1, 1, whatever. Right, odd into odd is odd. Odd square is odd. So this is odd. Very simple, right? Z into x minus y wholes x minus y square is even. This is odd minus odd. Odd minus odd is even. Right? 3 minus 1 is 2. Right? Or 1 minus 1 is 0. And this is even square into odd. What is odd and even? Even square is even. Odd into even is always even. X plus y minus z. Right? Odd plus odd is even. Even minus odd is again odd. Odd square into odd plus odd, which is even. Odd square into even. Odd square is always odd. Odd into even. Whenever even multiplication is there, it is always even. So this is even. This is difference of odds, which is even. Sum of odds, which is also even. Odd plus odd, which is odd. Sorry, odd plus odd minus odd. Right, two odds, one, two odds, odd plus odd minus odd. This is also odd, right? You can directly, so for example, 1 plus 1 minus 1, you can directly see it like this. Right, 1 plus 1 minus 1 is still 1. Right, that is odd. So even into odd, that is even only. Right, whenever any multiplication even is there, that will remain even. So this is wrong. And what is the other one? This is true only, right? This is true, and this is the one that is wrong. Right. Similar question in CAT 2001. That was in CAT 2000. This is in CAT 2001. Here we are told x and y are odd and positive, and z is even and positive. Earlier all are odd. In this case, z is even. Right. This is odd. X is odd. Odd minus even. What is this? 3 minus 2. 1. That is odd. Odd square is odd. 1 square is 1. And what is y? Y is also odd. 1 into 1, which is odd, right? So result is odd. So this thing is wrong. Then x minus z. What is x minus z? Z is even and x is odd, right? X is odd. 1 minus 0, 1 into y square. Y square is odd. 1 square. 1 into 1 square. 1 cube. 1. That is odd only. X minus y. X and y are integers. X and y are odd. X minus y. 1 minus 1. 0. Right, 0 into 0, sorry, 0 into 1, even into odd. So that is even. Similarly, x minus y, this is odd minus odd, that is even. 1 minus 1, 0. 0 square is even only. And what is z? Z is even into even cube is even. So for simplicity, I have taken 1 and 1. It did not take 1 and 1 because it is said that these are distinct integers. You can try with 1, 2, 3. Right. Then you will not get multiplication with zeros also. But still, it doesn't matter. Whichever numbers you take, this results always good. So this thing is actually wrong. This is okay. This thing is also wrong, right? X minus y. X and y are odd. Even into odd. Even into odd is even. Right, guys? These are such very, very basic problems. Hope you like this. Thank you.